Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the 9th chapter of 9th standard science subject that was on gravitation. So in my previous video, I actually explained what do you mean by gravitational force, and I also explained universal law of gravitation. So in this particular video, I will be explaining what do you mean by free fall. So there is one concept in this particular chapter which is known as free fall. So what do you mean by free fall? Generally, free fall means whichever object which is there in air on the Earth's atmosphere, on the Earth's surface, will be freely falling towards Earth. So that means any objects which are under the influence of Earth's gravitational force will come to a free fall and fall towards the surface of Earth. Basically, they fall towards the center of Earth. Since we have Earth's surface, so they come and fall onto the Earth's surface. So for example, now if we consider same example where an apple which was dropped on Newton's head from an apple tree, suddenly when this apple was detached from this apple tree, this apple had only Earth's gravitational force influence. So because of this gravitational force which was applied by Earth onto the apple, suddenly apple was pulled towards Earth. Before detaching from this tree also, this apple was experiencing the gravitational force of Earth. But the tree was holding that particular apple. But when that holding became weaker and when this apple got detached from tree, now tree doesn't have any hold, or tree doesn't have any necessary amount of force in order to hold that apple in air. So now apple suddenly got detached from tree and it came into the direct influence of Earth's gravitational force. Before also Earth's gravitational force was applied on this particular apple, but that force was overcome by the force of tree, where tree was holding that particular apple. Suddenly when the apple got detached from the tree, it came into the influence of gravitational force of Earth directly and it started falling towards the Earth's surface. So now you can consider apple has a free fall towards Earth. So now if you throw a particular stone to the sky, so for example, if this student is having a stone and this student feels like throwing stone towards sky, this particular stone will reduce its speed as it goes upper and upper, and at a particular point this particular force is exhausted. At that time this stone stays there for a while, for a few milliseconds or microseconds, I don't know exactly. It stays there for certain amount of time, and suddenly because of Earth's gravitational force, that stone will start falling towards Earth's surface. And that particular fall of stone to Earth's surface can be known as the free fall of stone. And while this particular stone is falling towards Earth, Earth is giving what? Earth is giving force. That means here stone is coming into the influence of gravitational force. So whenever there is an influence of gravitational force, or whenever there is an influence of force, now you can remember the previous chapter. What force is made of? Force comes into picture only when there is acceleration coming into the picture. What do you mean by acceleration? Acceleration is change in velocity with respect to time. So whenever there is change in velocity with respect to time, acceleration is there. Either it might be a positive acceleration or a negative acceleration. So basically we call that as acceleration and deceleration. Whatever it might be. Whenever that change in velocity is there with respect to time, and if that particular object has certain mass, then force comes into picture. Because according to Newton's second law of motion, force is always equal to mass times acceleration. So now this particular object or this particular stone which is falling towards the Earth's surface has certain mass. Now stone has certain mass m, and this particular stone is in the influence of gravitational force. So let us call this gravitational force as capital F. So this capital F is the gravitational force which is given by this Earth surface to stone. and because this stone is under free fall, it is falling towards the earth. That means there must be acceleration, because when force is coming into picture, acceleration must come into the picture. So that means here there might be certain amount of acceleration applied on this stone. So that shows whenever force is there, there is acceleration. And this particular acceleration which this stone is getting is known as acceleration due to gravity. Because due to gravitational force, the stone is getting the acceleration. And this particular acceleration can be represented as small g. So always remember, whenever I put small g represents acceleration due to gravity. Why we are calling acceleration due to gravity? Because this particular acceleration is coming into picture because of this gravitational force. So whenever there is force, acceleration comes into picture, and whatever acceleration is coming into the picture due to the gravitational force of earth, that acceleration can be known as acceleration due to gravity. So whenever you are doing certain experiment, you are considering only small patch of earth. So if you consider this as earth, then only that particular small patch on that earth you are considering for an experiment. So that's why the acceleration due to gravity is considered to be constant throughout this particular patch of land. But if you move towards the pole of earth, the poles of earth are very much near to the center. So now I'll just draw an earth's image. So basically earth somewhat looks like this. So here I'll draw one more image. So let us imagine this as earth. So this is north pole and this is south pole of earth, and this is the equator of earth. So at equator, the distance from equator, from this particular position to the center of earth, is more compared to the distance between pole and the earth. So if you consider this as D1 and this as D2, D1 is greater than D2. So that's why acceleration, gravitational force at equator will be little less compared to the gravitational force at pole. So almost earth is in round shape. We consider that gravitational force is almost same throughout the earth's surface. But you should remember, gravitational force will be slightly more on north pole and south pole and slightly less in equator. So because gravitational force is slightly more on poles and slightly less on the equator of earth, so acceleration due to gravity will also be little bit less and more compared to equator and poles of the earth. So gravitational force at north pole is little bit higher, so acceleration due to gravity will be little bit higher compared to the acceleration due to gravity at the equator. So generally, experimentally, we have got to know that acceleration due to gravity of earth is somewhere around 9.8. So I am just writing this particular symbol. So I am just writing this particular symbol just to have an idea that approximately acceleration due to gravity of earth is equal to 9.8 meter per second square. So this particular acceleration due to gravity, you can consider this to be constant throughout the earth's surface, because there is no much variation in gravitational force at north pole and equator. Yes, of course, slightly gravitational force is more in north pole and slightly less in equator, but when you compare that with the gravitational force, the entire gravitational force, there is only negligible difference between the gravitational forces at north pole and south pole compared to the gravitational force at the equator. So that's why approximately we consider the acceleration due to gravity is equal to 9.8 meter per second square. So always whenever you are solving any problems, you should always remember acceleration due to gravity will be 9.8 meter per second square. Even if in the question, if they have not mentioned the acceleration due to gravity, still you should remember this, because it will help you in solving problems. Now we have this value 9.8 meter per second square. How did we get this particular value? So in order to calculate that, we can just consider an earth and we will consider one particular object which is just lying on the surface of Earth. So this particular object will be having mass small m, and this particular Earth will be having mass capital M. So now always remember, gravitational force of any object will be acting towards the center of that particular massed object. So that means here gravitational force of Earth will be acting towards the center of this particular Earth. So the distance between center of the Earth to the object which is there on the surface, you can consider this as distance d. And if you assume Earth is almost round in shape, then you can consider this distance as the radius r of Earth. So now you have the distance, now you have mass, and now you have mass of Earth as well. So here force, gravitational force is equal to capital G into capital M into small m divided by d square according to universal law of gravitation. So F is equal to Gmm divided by r square. So now we all know that force is gravitational force which has acceleration due to gravity, that is force involves acceleration. So here force is due to gravitational force of Earth, hence we are considering this as acceleration due to gravity. So instead of writing F is equal to mass times acceleration, I am writing F is equal to mass times acceleration due to gravity, because this force is gravitational force. So in the place of F I am writing mg, in the RHS Gmm divided by r square will be there. So here this particular mass m and this particular mass m is cancelled, because why I am considering small mass m instead of considering the Earth's mass is because gravitational force is acted upon the object. So here Earth's gravitational force is more, so we are calculating gravitational force of Earth. So gravitational force of Earth is acted upon the object. So that's why we are considering the object's mass. So here small m gets cancelled. We get an equation G is equal to small g equal to capital G into m divided by r square. So now we know what is the value for G. So G, small g will be equal to capital G. So the value of gravitational constant is 6.673 into 10 power minus 11 into mass of Earth is calculated to be 6 into 10 power 24 divided by radius of Earth is calculated to be 6.4 into 10 power 6 meter whole square. And if you calculate this considering all these powers properly, you will get G as 9.8 meter per second square as your answer. So by substituting the mass of Earth, by substituting the radius of Earth and gravitational constant, you can calculate the acceleration due to gravity. When a particular object which is under the influence of gravitational force freely falls onto the Earth's surface, so that means that object is not held by anything, it is just in the influence of gravitational force and it is falling towards the Earth's surface. So such kind of objects is following a straight line towards Earth's surface. So here you can apply equations of motion which you have actually learnt in your previous chapters. So equations of motion, if you just recall, first equation of motion V is equal to U plus AT. Second equations of motion is S is equal to UT plus half AT square. Third equation is V square is equal to U square plus 2AS. Here S is distance. So here wherever acceleration is there, you can just give acceleration due to gravity, because any object which is freely falling onto the Earth's surface will be having gravitational force influence of Earth, and whatever acceleration it will be having while falling onto the Earth's surface is acceleration due to gravity. So that acceleration due to gravity acts as the acceleration, and directly you can substitute that acceleration due to gravity in the place of acceleration and you get new set of equations, that is U is equal to V is equal to U plus GT, S is equal to UT plus half GT square, and V square is equal to U square plus 2GS. So this will be your new set of equations of motion. So this will be your new set of equations of motion, especially when objects are under free fall, they are under the influence of gravitational force, and because of the that particular gravitational force, you can apply equations of motion onto that free fall objects, and wherever acceleration is there, you can substitute acceleration due to gravity. Based on these equations, you will get multiple questions. So that questions you have to work out. And also in exams, if they give any kind of questions, you should be able to use these equations of motion, and you should be able to use the universal law of gravitation, which I have discussed. Based on that equation, you can solve the problems which are there in this particular chapter. So those problems I'll be discussing in my next video. So till then, if you want to learn more physics, chemistry and mathematics related to 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel.